So we discussed that various components. Let's move on. So we have the concept of boundary. So whether it is power plant, steel plant, any product, we start with block flow diagram. And we already discussed boundary and block flow diagram. So there's a block diagram. So you have the component, fence line. It's a just example, but concept is similar. Help tree. So you cut the tree, and in Australia, as I said, we've got 2 million hectares of land, and half of my career, I would say, I started, if I say 1995, and this is kind of, so 30 years, 10 years of my career was in forest industry, because I studied originally forestry degree. And then another 10 years mining minerals, and last 10 years energy. So it's a kind of mixed environment, industries. So I feel like privileged to study these sort of areas. So how to grow trees, how to plant trees, and how to cut trees, I know very well, and technology in relation to that. Basically, you need plants, and then no other plants, right? All these wooden plants. And in Australia, there are so many sawmills, very sophisticated, automated. Not many people. They are. It's like a steel plant essentially, very much modern sawmills. I think I have been to all plants. I think there are most of the plants, multiple times, some of the plants, because of my work and work in the industry. So I think my PhD scholarship was funded by a company called Boral in Australia. So they are like in the stock market there, what they call Sensex, isn't it? So we call it ASX, Australian Stock Exchange. So Boral is one of the number 3 company in the manufacturing sector. So Q1. The mining is very strong in Australia. Manufacturing, some not many. Boral is one of them. Boral bricks, Boral timber, Boral plaster, Boral cement. There are many construction companies. Then we have got mining, manufacturing, and then we have got banks. They are the main. If you talk about stock market, major capital and players, these are the companies. Except one, it's called CSL. So that's called Commonwealth Serum Limited. Basically, during COVID time, you remember that. So I think they produce blood stuff and also medical field, and also I think COVID vaccines, things like that. So they became suddenly, I think, $300 billion company something, and became maybe 500, I don't remember, but then 200 billion became 600 or 500 during that time. They dropped back, kind of, it's still probably quite a big company. Manufacture like AstraZeneca vaccine and things like that. CSL is our main. Here, what's the company here manufacture vaccines? Serum Institute.
Covaxin.
So they produce 60% of vaccine with a low by something like that. So things like that. Yeah. So CSL kind of similar company. So what I was saying is Boral sponsored my project, and Boral has lots of sophisticated sawmills, and part of my PhD was, so you imagine Australia. So Sydney is Sydney is the largest city in Australia. Melbourne is the second largest. None of them are capital. Capital is Canberra. Canberra is very small. Whereas Sydney to Melbourne is about, I don't know how many, about 1,000 kilometers, something like that. So there was a fight who won, and then okay, let's make it a middle kind of. So although the Canberra is towards Sydney, and it's a small restaurant in Canberra 3 weeks ago. Very nice, small, white. A lot of people like that. People maybe want, and majority of maybe 80% of Canberra people are employees of government kind of. That is the capital. So Sydney, and then our north city is Brisbane. So Sydney to Brisbane about probably 1,600 kilometers or maybe 1,500. I can't remember exactly. So that's around the like somebody told what they call Coromandel Express. It's Bhubaneswar to Vizag or from Chennai. That's right. So like Sydney to Brisbane, we have a nice train line also, and we see a lot of Australia, and we see if you can go to Australia. I recommend them travel. So my job, so that Sydney to Brisbane, there are lots of mills. So I've been to many sawmills, Optimus, Russian, things like that. So that was my kind of PhD, and I did very well. And actually, to some extent in Australia, that gave me the working with the industry and how you make research applicable. And I think I did well in CSR because of the background. The CSR also like that kind of people who are researchers, but at the same time research for practical applications. And so I think that was a good job. But on the other hand, what I was going to say was my part. But essentially, in Australia, the plantation-based industry, forest industry, is very, very that time that was mostly eucalyptus, and later they moved to radiata pine. This is pine timber methodology. You know that's it's industry, and that's also interesting. During the Second World War, a lot of people lost jobs, unemployment was high, so they planted trees and they started vacant lands, and that suddenly become $1 billion, $4 billion industry, which is good that because those plants grew and they cut and then they replanted. So it's a cycle. It's a nice what they call amount of planted and amount of harvested equal. So it becomes a very nice steady industry. So no issues really. So it's a support establishment. So then plants, and plants is the input for a shed. And as I said, somebody said that steel nails, and then that you to make a steel electricity core, flat side, or we talked about that, etc. And then another thing is waste. So a lot of people, plants also, the furnace need electricity because they're very precise. You have got a log. Have you seen heavy videos? Yeah, you know that they go nicely, first they'll debug it, and then they'll laser make that how many cuts they can have. Very, very optimized and planned way. So chips first again, and then make four what they call I forgot that name, square shape kind of wooden block, and rest of them wood chips. They go to the particle board mill, medium density fiber board plant. Australia used to export a lot of chips for paper, converting of paper. Paper you can take that one, so nothing is wasted. And then that four square block, then they come into small sections, and then that is dried in a kiln, like room like this. They will fill it out and steam drying kind of. So then my job was to model this skill and also the software to run the machine. So that kind of work especially. So that itself is an industry, and I'm not sure here most of the wood is imported or locally grown like this, right? Locally, what's the most popular wood here?
Sal, teak, gar.
It's a kind of slow growing, very hard, right? Furniture you can make out of that here. So we can go to that one. So that food production process change. So I visited. That's why I was telling that because of my background, whenever I go, I like to see the forest.
Sir,
Yes.
sorry to interrupt. So we are discussing about the technologies to reduce emissions, right?
Yes.
So when will that part come?
When that part comes.
Yeah.
So actually, what I'm going to show that how to calculate emission for a wooden shed, and how that can be implemented in the context of a power plant. So I don't think I'm going to give too many tools that I'm aware of in the power plant emission, but more on the LC and calculating power plant emission. That's the job first. If you understand that, then you can think about the.
Still, what are the major practices that are being followed right now for reducing emissions? We want to know about that.
I will probably tell.
I was expecting on that sort of thing.
Hopefully, towards the end, I
This is
will.
like skirting around the issue. I am only interested in that. The major technologies that are being used and how we can replicate that in our respective work.
So if you go to the point, so you are talking about what is the technologies to reduce emission in power
Yeah, we
plants.
can discuss about that and be more fruitful.
Okay, so then that's what I can tell. Before that, you need to know how to calculate emissions. Are you confident that you know how to calculate emissions?
Still, you gave a basic idea.
You can do that.
Technology.
So I'm going into deep end of this schema for software, how to calculate the emission first. Then you can talk about the technologies to reduce emission. Okay, so that's important. I think that you need to know how to. There are lots of pros and cons. How you calculate the emission. Okay, so that's my view. But I think I'm going through that quickly. That's not a big job. Anyway, so that's sort of life cycle modeling. So if you have a power plant, doesn't matter. I mean, whether power. I'm not expert in power plant. I'm not expert in steel industry. I can give some tips and tools that how to. It's not necessarily I'm expert on the technologies for power industry, but I know how to calculate emission for power industry or steel industry. And then once you know that one, where the emission is coming from, you can think about emission. So if you talk about power industry, so okay, let's see that. Let's tell that. So I've given you that what is the kilowatt hour, what is the kilogram CO2 footprint per kilogram per kilowatt hour electricity, right? You know that one. You can ask me question also rather than presentation, you can ask me question, I can answer that one. Okay, that's another way to interact. So say a power plant product. Here I believe power plant and also steel plant. Doesn't matter again, but that's what I'm saying, doesn't matter what product you are producing. So in this case, various inputs is going through, and if you develop a model like that for your power plant, in this case it is that shade is giving the maximum impact. So you need to look at that technologically. So in your case, a power plant, what's the production? Power, right? Electricity, kilowatt hour electricity. Where do you think that most emission will come from? Coal. Maybe it is coal-fired power plant. I'm interested in what kind of power plant. Okay, let's discuss question and answer. So what's the power plant you are talking about? So thermal power plant. So what is the main input for thermal power plant? Coal. So if you look at a power industry emission, you look like diagram like that. What do you think that red line would be? Coal or what? Any other input you can think of?
Water.
Some water. So water and coal, nothing else. Power plant is relatively simple concept in that case. So if you want to reduce emission, what should you do? Replace coal, capture CO2, replace with renewables, right? Or you can, what else you can do? I guess recycle, make the efficient system, right? Coal has got various types, as I said. That so what kind of coal we are using?
Sub-bituminous.
Sub-bituminous coal. What's the energy content of that?
Around 5,000, 4,000 to 5,000 kilocalories.
So that means sub-bituminous coal, right? 25 megajoule per kilogram.
Gradation is there.
So it could be 20 to 25 megajoule per kilogram. If I go with that British unit, I don't understand that kilocalorie unit. I probably, but if you say megajoule, you go British unit, it would be 22 megajoule per kilogram, right? Something like that. So megajoule kilogram, or say 20 to 25 gigajoule per ton, right? That much energy. Now let's discuss in terms of, so that the primary energy, right? So that's the primary energy. Converted, first you burn it. So if you burn it, what's the efficiency of the boiler? It is 80%. So that 22% of 80% of that you are getting, right? So you are losing already 20%. So that in megajoule, so 22% becomes 22 becomes 20 megajoule, and 20 megajoule power, 20 megajoule, that's thermal power, right? Still we are not making electricity. Still it is thermal boil heat, isn't it? So that is heat going to where?
Water, heat the water, and the water converts to
Steam
steam.
So that goes to the steam,
Yeah.
and you lose some more. What's the efficiency of that? Overall, say I started 22,
35%.
so 35% of that. So say 22 times 35, so that becomes 7, isn't it? Something like that. 7 megajoule equivalent electricity conversion, right? Something like that. So that means 2 kilowatt hour, kind of that, 2.2, something like that, isn't it? Yeah? So that to increase that efficiency, if I want, say, I want make it 50%, 22 becomes 10. What are the processing, what are the possibilities are? How do we make that power plant efficient? Any idea? What they call, so this is we're talking about conventional pressure, temperature, isn't it? Right? If you increase the pressure, if you increase the temperature, then potentially what they call that high temperature, high pressure system, and potentially you can increase the efficiency, right?
Supercritical. Yeah,
Supercritical. So you are talking about subcritical, right?
Yeah.
Subcritical. So if you go to supercritical, so to do supercritical, what do you need to do? Invest in boiler, I guess, right? So that comes into that
Structural changes.
cost issue, capital cost, right? Do you know, I think obviously that needs the company will ask you that how much money. So that's called technical economic evaluation, right? So So that's again you have to do that calculation, the technical evaluation, and all. So that's one way. So that's a cost. But at the same time, you need to show what's the CO2 footprint potential reduction also possibility like that. So that's why ultimately that evaluation and this evaluation requires mass balance, energy balance, flow sheeting. These are the three kind of key skill set any engineer or those proponent has to know, and what are the techniques that LC is a technique. So that's I'm going to show you that how to calculate. So as I said, it's not necessarily we are giving you the solution, but we are giving you how to evaluate a technology. If you have a technology, then there are technologies people are offering all sorts of technologies, supercritical technologies. You say that one. There are, I guess, carbon capture. That's one story. Carbon capture and utilization, another story. Because power plants have not many options. Or switching completely the hydrogen, that could be another one. Hydrogen combustion could be another one. But before hydrogen combustion, same story like where hydrogen. How do you produce hydrogen at cost that will. Do you know what's the energy content of hydrogen, by the way? Anyone? What's the energy content? We said 22 gigajoule per ton of coal, right? Or 22 megajoule per kilogram. Hydrogen is 120 minimum per kilogram of hydrogen. 120 megajoule. So how many times? 6 times, something like that, isn't it? So hydrogen is 6 times more energy density per unit mass. But per unit mass not on the solution, because you have to also carry the material, and then volumetrically hydrogen is very low volume. So what's the volume of coal? What's the density of coal? Anyone? It says, I don't know, 700 kilogram per kilometer, maybe something like that. Hydrogen is less than 1 kilo, even it is a kind of compressed form. So that means 700 times less. So you need more. So how do you manage that one? Does that mean that your boiler has to be changed? So that same amount of heat you can put in, because ultimately you need to get same amount of heat, so you need to have bigger boiler, bigger combustion chamber, right? What about blending? Blending with say natural gas. Is there any gas fired power plant anyone running here?
In our plant.
Gas fired. So what gas you are putting this?
Open and blast furnaces.
And so gas. If someone has gas, can we easily blend hydrogen? 10% say.
Energy balance.
Do you think 10% would make any difficulties? Maybe not.
Can't say.
So say you have got port, you have got another port for hydrogen. It should be.
We normally use 3 gases: blast furnace gas, coke gas, and propane. We have propane contract, so we sometimes use propane also.
Propane also. So that's sort of, these are the technologies. When you calculate, you don't have a lot of choices, but these are the sum of the interventions you can make to reduce you. Does that kind of give you some flavor? Or what else you need? What else you need?
I don't need a kind, I want the actual subject, right? For example, there are ESPs, that's in the stack emissions.
What is that? ESP?
ESP.
So CSP means that
ESP, sir, ESP. Electrostatic precipitators.
Your company.
My company, ESP is a kind of technology to reduce the
Electrostatic precipitation, that's the fly.
They capture the fly.
Fly capture.
Yeah.
Extraction process. Okay. Then ESP.
What are the latest technology that are being used all over the world?
Yes.
Like rubber technology and all. So that kind of discussion I was.
But that's more on the ash and waste utilization.
That is what we are working on.
Right. Okay.
So we need to improve on that.
So
we
now-
need a discussion on that.
Yeah. Because I don't have expertise on ESP, how you catch.
Because I mentioned in the module, I was expecting this kind of subject to be discussed.
So again, how much ash you are, say per unit of kilowatt hour energy you produce, power you produce, what's the ash number? Do you have any number like that? How many tons or how many kilogram ash you produce? No. So 40%.
40% of total coal burn.
So say we have got numbers. So those sort of numbers are important I think, before going into further discussion. Now say you have a number, okay? Now where they're going at the moment? What they do? What do you do? You dispose of the asphalt?
We use it for the cement factory.
Cement factory, right?
Road.
And that's a new development, right? Last 5 years or something? Yeah. So geopolymers, you were talking about, you can make various structural materials, that's where you can compensate. So how you calculate that? Say, if you put ash in a product, when that product is not used, so you need to calculate the CO2 footprint of that, right, that product. You save some CO2, you can get back your system that, okay, I produce power, I produce this byproduct, this is the CO2 footprint, I can claim that, so ultimately you are reducing CO2 footprint of your power. Does that make sense? Indirect way of calculating. So ultimately you need to calculate that one. Until you need to generate number, you need to quantify.
Sir,
Yeah.
like we are supplying our fly ash, dry ash to the cement industry. So the fly ash based cement that the cement industries are producing, so they are replacing ordinary Portland cement with, they are replacing 30% with the ash. So the 30% of the ash that is being replaced, because of that, the 30% less material, other materials that they otherwise would have used are getting reduced with the cement industry. So do we get the benefit of CO2 reduction for that 30% of the ash?
I think so, because you can reduce the CO2, it's called substitution of kind of another product where you are making benefit for that one. So overall, so it's a kind of accounting system. You need to check against a standard and what sort of investment you are making in terms of energy cost to process that ash also. That's, you just transporting it probably, right? So you have to do those calculations. At the end of the day, as I said, it's accounting and it's a summation of all these components, but you have to do properly. Make sense? That's right. So you can, so these are the ways people are making and trying to portray that technology or product is benefiting society, but at least sometimes less CO2.
One of the things I just add to what he asked, like the technologies that being adapted to as an alternate fuel, ammonia is being used as a co-mixing with the coal. So what Japan has done, they have replaced all the thermal plant with 20:80, like 20% ammonia they are co-mixing with the coal. So the consumption of coal is getting reduced by 20%, and that is reducing their carbon dioxide emissions. So that is one thing that is happening in Japan has already done, Europe is doing. In India, only one unit, Adani has like as a pilot project, they have started with one of their units at Mundra. So to co-mix ammonia with coal, 20% ammonia with 80% coal. So that technology is there. That the patent is with, I think, some Japanese company, Kowa or something like that.
So I had discussion with that Adani, and that work actually was supposed to do the calculation. So but anyway, we couldn't work with Adani for other reasons because of the regulation and other things. But essentially, I know exactly what you're talking about. So that's so. But now you have got 20% ammonia, 80% coal. Ultimately, you need to produce 1 kilowatt of electricity. You need to provide certain amount of energy. What is the energy of ammonia? How you get ammonia? What's the cost of ammonia? Right? These things you need to know. And then you blend them together. Ammonia means NH3, right?
Yes.
And the issue of NOx emission, it will, but NOx emission is relatively easy to control. Is it
Easy to control and it's pretty less.
So but now
Within the
ammonia,
consumption.
what kind of ammonia?
नॉक्स कंट्रोल कहाँ हुआ? डिनॉक्स लगाने के बाद भी नहीं कंट्रोल हुआ, तो सीपीसी भी अपना रेंज बढ़ा लिया। पहले 300 था उसका, 300 नहीं कंट्रोल।
Like CPC, they are saying that because the NOx was not getting controlled, the CPC, the Central Pollution Control Board, has increased
the limit from 300 to 450.
So that people can
So that
blend
they-
that. So now
allow the
has increased slab so that you can blend something. Now my question is that what kind of ammonia are you talking about? Grey ammonia, or blue ammonia, or green ammonia? And if you talk about green ammonia, then green hydrogen. So you need to know the story of hydrogen because ultimately that's the starting point. And now hydrogen story means renewable energy, isn't it? Is that kind of link? So you need to you need to have a very broad view and evaluation capability. And many power plants, I can tell that many power plants have that certain skill set. They don't have to look at everything. And that's where I'm coming from. That you need to have a multiple kind of skill set. Does that make sense?
So what your expertise is, like the ammonia and coal co-mixing is feasible for the future, or like it's not a good
Japanese
thing?
are doing it, obviously.
Ah.
Japanese are the big promoter of ammonia technology. They have gone on, I've seen some of these activities. But again, what you need to have a supply, and security and sustainable supply of clean ammonia. If it is not there, then just normal, if you make ammonia from natural gas, you do CO2 emission, we know that one, right?
Yes,
So
yes.
you add 10 or 11. So ultimately, everything you do, if you don't know and calculate how the net CO2, that was the job. Basically, Adani wanted to know what is the net CO2 reduction, what is the cost per dollar per megawatt hour, with all this blending and all this calculation, etc. Because each unit dependent on another unit, you need to go upstream and even up to hydrogen production. So that was we were told.
They are using green ammonia or
So I think it has to be green ammonia. It's a hypothetical.
otherwise CO2 reduction will not be very much.
Otherwise not benefiting. That's my view. Yeah. I mean that you have to put some. It's a context based. It's a location based. It's a situation based. There are so many factors. What's the current efficiency of power plant? What's the current technology? Is it subcritical? Is it supercritical? And with that, that's also helps because ultimately if you have a supercritical technology, you're already quite efficient, right? So as I said, if you have a power plant, you introduce CO2 CCS, then your efficiency goes down. So if it's a black coal power plant already at low efficiency, you go further efficiency down. What's the point? If you have a very high efficient plant, maybe you can think about CCS. So, but this has to be case by case, and I cannot give you answer in 1 hour or 2 hours.
Yes.
It is a project. It's a probably $200,000 project, right?
Yes.
You have to over the time collect data, set up teams. So you cannot expect the answer right now about. You understand what I'm coming from? Right?
Yes, yes.
So you set up a team, develop a kind of protocol, invest some resources, and do that calculation and come up with a solution. So, but these are whoever you go to, they will be using this kind of approach: the flow sheeting, the workflow diagram, the capex, the opex, and the techno-economics, the life cycle assessment. Because ultimately, getting some benefit, some credit from that, and that's how probably has to be stacked up ultimately. And then make a decision, next decision. Any other question? So anyway, let me go through that one. You can see that one. This is very powerful diagram. You can see whether it is power plant or steel plant, bottom up, and you see that where the emission coming from. So this is the software.
What was the data written on the slides, on the box?
Sorry?
What was the
These are the data. These are things what is written. So for example, you can see this is the steel. So steel contributes significant to the shape, and still obviously if I go further down there will be electricity, coal and flux, etc. Right? So that also that you can see some electricity also there, electricity going to the plant making, the plant is there. So it's not necessarily, it's not relevant to power plant obviously, but the concept is, I'm giving the concept is same. That's what I'm saying.
You are using some kg, 96.5 kg.
Exactly, 96.5.
What is this?
So that's 96 plan is used, that is in the database, that's the software already. So you need to know that how much plant you are making a product. The building, how many steel, how much concrete, how much, everything else, you put them together and then you calculate. And that's how, in a sense, power plant is a relatively simple story, but buildings and etc. is more complex than simple. So my expertise is more on the LCA, that's what I'm going to tell you, that I'm a lot of experience in LCA. But it is the similar, doesn't matter what product you're producing. So this sort of screens will get not very clear, but essentially it says that, for example, the data, as I said, data is important. Time period, which time period that they are collected. Geography, where it is, because it's location to location values. You have got qualified power plants, some countries have got high, completely high power plants, right? So those are the different. Technology, average technology or new advanced technology. Then the average for a specific process, I mean, it's that what kind of process you're talking about. Then allocation, multiple products. So that's what I'm saying. A power plant is producing only power or anything else?
Is there any demarcation it will be average technology mix?
So sometimes that the gentleman was calling about new technologies. So new technology may be likely that the emission will be low. So you need to then specify that one. So that's all about that, the data. Then and main problem in many cases, if a company is producing multiple products, so steel plant, it is producing steel, it's producing other products also, isn't it? potentially the power plants, the power is the main product, but they may have appliance, they may have some other products, right? So those may heat, and on some opposing plant, they may have some heat, right? So those more products, that becomes more difficult. How you assign the impact or footprint to multiple products. So there are techniques to do that. That's the standard, say that you do this way, that way. You can go by physical, say, mass basis allocation. So you say 20% of the feed becomes a product, another 10% another product, maybe another 5% another product, like that. You can assign percentage basis, but 3 products, the price is different. They call it economic basis. If it is price is different, then say a mine is producing gold and say steel, or gold is still not a good comparison. So gold and copper, okay, could be one mine. So if you go by mass, gold will have no impact at all because it will be a very small percentage of the mass. But if you go by price, then it will be big because gold is expensive. So those things are in this particular, I'm not sure. Are you aware of these kind of things at all, or how this is done? Anyone here? How allocation is done? When you want to how you allocate? No? So these sort of things are problems. So that because if you don't, people don't, how do they decide? Okay, one product. It's the same with the costing also, because you are producing power, you are not putting any value or revenue for fly ash, right? Or you do some fly ash, and fly ash is small revenue because otherwise you have to dispose it, right? Now that kind of skill set required, because then 2 companies talk 2 different results, it will be not matched. But if they follow the same process of allocation, or same standard, then that will be, and that's why the engineers, I would say, from what I say, that engineers need to be aware of that when we do the evaluation. And that's a bit of contention, debate going on which one I should choose. Because we don't have enough information and it is not done properly. So that's where I'm coming from. So that is the software that got that process. So software has got lots of materials. If you say energy, energy is heat, electricity. And in electricity, you can get all sorts of electricity production by fuel, electricity by country. So Indian, probably all of, as I showed you that before, the various power plants it has got. So in India, so that electricity by coal, by brown coal, by diesel, by petrol, by nuclear, by hydro, by anything you name it, solar, everything is so that's the having the software, it helps you. Otherwise you have to generate your own, and that takes a long time. So that's when I started my career, there was 200 processes, I would say. Now it's 20,000 processes like that, and it is already filled by the database. And that's the saves you time. So you can carve a tree, you can with an axe, or you can use handsaw, that kind of thing. So it saves time. So this is the, I would say, the new people who is doing this kind of work, the evaluation of technology and choice or selecting technology, they need to know these things.
This is the software itself.
That's the Singapore software. Singapore.
So that for these locations and all, these are all failure, it is all over the world, or it's country specific?
Country specific, but there are some data slowly they are coming. As I said, Indian electricity data is there, but maybe they are not up to date. I don't know. That sort of things, who can evaluate that? I cannot evaluate Indian data, I don't need Indian data. But Australian data, I have good understanding. So unless you cannot negotiate, you don't know, then you don't know, that kind of things. That's why the local expertise need to develop and maybe contribute, question those data so that the better results, better LCS will come. So that's, you can choose that, you can create new, and then there will be like that. So this is pretty straightforward. So there is documentation, inputs. So you see that one, anything you make, you need something from the nature, right? Something from the resources. And there will be inputs from nature, inputs from, electricity or thermal, all these inputs they are laid out, and how much you are putting in, and you can have parameter, description, etc. But here, ultimately, you need to know what is going in, what is going out, essentially. That's the input-output kind of table direction. And I'm sure that if you are running a power plant, you have that number, right? You know exactly what is going, because they're paying for those coal or whatever. So, but I know that companies have that data, but they don't know how to translate that data to medicine. That's where we are coming from. So then you see that one, nature, atmosphere, materials and fuel, electricity and heat, and you can pick Indian electricity. I need 100 kilowatt electricity for me to this thing. And that 100 kilowatt electricity comes from a coal-fired power plant, or gas-fired power plant, or cogen plant, or hydro plant, whatever you say, or you can mix your own or particular grid. So these are flexible also. And then you can put those in and details. You have to use a sensor, and sensor might use petrol, it might use electricity, and then waste scenario. And a lot of people, as you said, that the power plants produce a lot of waste. We do not, everybody is concerned about carbon, but what about waste? And waste may be biased good thing that can be used in another industry. But is that accounted in a way, quantified way, so that we can claim that benefit? So that's how you develop the model and slowly build on. So it's a nice way to build from ground up. So you have a small block model and then it goes like that. And that's what I'm saying that one. That's the way. I think I'm not saying that you need to do this software, you must have to that one. That's the concept. It's the fundamental understanding that how the technology, how a product is evaluated on the same basis. And there are methods, they call it. So that's when you say that IPCC method we are using or any method, there are a number of global methods. So these are kind of, if you don't know what exists, then you cannot choose. What's the benefit of having one method against another? You can have multiple methods and analyze that and see that the result vary. If it is very significantly, therefore one of the method. So that's because these are sometimes location specific, because India has got certain geographical circumstances. Another country has got another, and nobody is going to work for your country kind of in the data is development. You have to develop your own. You have to develop skill set, you have to develop data properly in the economy. And you can see that once. So these are the indicators, so global warming, climate, ozone, etc. And what, so this is called hotspot analysis. So you can easily find which part of the process is contributing most, in this case shade or waste or as many as we can describe it. So that say next steel, is that core component, is that flux, is that scrap or whatever. With the power plant scenario, you can have the same thing, that the fuel power plant, as I relatively simple with coal fired power plant, you know the coal will be the main contributor. And then you can think about switching or having better quality coal. So these are the various ways. So and then again, so that these are the indicators. That's ultimately knowing that indicators, you need numbers, where they're coming from. That sort of table is very powerful to analyze your product, your system, so that you can come up with a solution. So I'm not expert in your industry. I cannot give you the solution, but I can give you the tools to evaluate and make decisions. And that again, you are valuing it. You change it to human health, ecosystem, and in many cases, if you say solar plant or renewable plant, particularly solar, needs a lot of land, and then these species destruction, ecosystem damage would be. So there may be some places where maybe coal is better because of it may be CO2 will be producing, but it is saving the forest, something like that. But that has to be location to location. I'm not saying that that's the true case, but you need to evaluate against another. And that's finally human health, ecosystem, resources, and you have got scope. And sometimes people do not understand it's too many complex. Okay, let's make it to 1 point, and you can say that one total point is so a technology in a sort of coal-fired power plant you are introducing. The point is 10. Another technology is 2 points. So if it is better, higher the point is better for that particular technology. So you need to evaluate like that. Human health again. So these sort of things, this is a software component I just wanted to talk about. Because I think ultimately the software will not help everything. You need to have some experience. Why you are doing that quantification for? Why you are working? Most of the cases I find that people want to introduce a new technology and they struggle to choose that and select that technology. Maybe even if you have a good understanding about the cost, that okay, it will save money, that we may have understanding, but many I find they don't have understanding about the environmental profile. And if we don't get environmental benefit, what's the point of doing this all the hassle, etc. Yeah, cost reduction is sometimes the driver, but I think most of the cases, most industries are pretty efficient. How much efficient you can make more? It's more environmental driver, and unless you quantify and record, I think people will question that's why we're doing it. Yes, Dr. Asaria, sir.
Suppose I have two scenarios.
Yes.
One factory is generating certain amount of waste which cannot be valorized. Another factory which is generating a waste which can be reutilized.
And valorized.
Yes. And what would happen to the waste which is not being accounted and landfill, which is not covering under any NEDA. Nobody is able to catch, but still he is managing. Material disbalances are canopies, for example. A scenario like that. How do you think?
So if you have already utilization situation, then you can have what amount of primary material or other material is replacing. That's called substitution effect. Okay? So you are substituting your product, your waste product against another product which is reducing the impact, you can claim that as a credit.
Credit.
Yes. And then, but if you don't have that, you need to generate some number, right? And waste has got so many different types: hazardous waste, non-hazardous waste, stable waste, and some waste can leach, So that's sort of, I don't know, I think most of the organization, government regulation, there are certain way you need to manage waste, there is a cost and environmental consequences because of not only leaching but also you need to probably transport long distance. So those has to be accounted. So ultimately, even waste is valorized and credited, but you need to do something probably. So that needs to be accounted for.
Suppose I have a beneficiation unit.
Yep.
Two beneficiation units. One is handling very rich ore, another one is low grade. The beneficiation unit which is handling rich ore will have a tailing of say 43% of the 63 input 43. In case of low grade beneficiation, you will have 38, 37 as the waste product. And there is a difference between the tailing, definition of tailing to plant A to plant B. So very poor, this is very rich. If this tailing can be sold, it can get millions of dollars.
Potentially.
And interestingly, if the tailing is lying there for a decade, and nobody bothers about the deposition. For example, in Durgapur still has a lot of wastage, millions of tons of material.
Sitting somewhere in the
Sitting somewhere, but nobody knows
and they
where
may
it
have
is.
some resources.
Yes.
Yeah. So you need to do some test work and see the extraction potential of the resources, how much resource you can extract and show, and if you have a plant, you can claim that. Because that's
That could be credit.
potentially that can be credited. By the way, fly ash may have some critical minerals, you know that one, right?
Yeah.
Is there any work going on to extract critical minerals or some special minerals in fly
Yes,
ash?
Xenosphere is getting extracted like Xenosphere.
Yes.
This is used
There's a
in
product,
Ah.
silica kind of product, is it?
silica and alumina. Yeah. Majority.
Another way I think I've seen that because it's mineral rich,
Ah.
so magnesium or sodium, some people are trying to extract through leaching using some chemicals, alkaline leaching or something or acidic, and getting that product and making more product out of that. That's a more high value, but where is the technology? How much you need to spend? Who is going to invest? And so those are kind of still early stage of research. So but that's the way if you want to get some benefit for power plant, those are the outside box things. But I'm sure that other power producers, same kind of situation like yours, but ultimately you need to have cost-effective, environmentally beneficial technology so that you can justify. Otherwise, you are doing right. If you think you are doing okay, then that's not work or to change. Ultimately, if something forces you to change, you will change, I guess. Does that make sense?
In China, they are extracting
Aluminum from the fly ash. I think fly ash, we just recently had a project we were trying to look at few rare earth elements from fly ash, but fly ash so fine, ESP material, outer ESP is fine material,
Yes,
very, very
yes.
fine, very difficult to handle. If you say you put acid, it has to be somewhere porous because it cannot go through. If it is not porous and permeable, then how you get the minerals out. So, and what I think a lot of people say we have is that we did that one, we characterize the fly ash waste, we sprayed that one, but the value is so low and it doesn't work because of the so fine material, it's hard to justify. So at the moment maybe construction, that's one way to do that, geopolymers, or maybe you can make some agglomerate, you can get
Some bricks are made by the fly ash.
some
Bricks.
bricks like that. Not only bricks, you know, we
Cement.
have one airport runway, whole airport structure is made from geopolymer fly ash. There are another issue, people say a bit of radioactivity potentially, depends on where it is. So but I think that can be handled. Sorry, your question?
Sir, like you said, the extraction from the dry ash is like difficult because of the nuisance that have because of the flying characteristic. But with the pond ash, the ash that we separate
It's a
separately,
little bit
that contains little bit coarser and it contains moisture about 15% in it. So can that be used to extract some like alumina or
potentially, because that what happens most of the industries, they think power plants, power is our product, forget about anything, right? Actually, yes, sorry, go on. Yeah, so I think you need to think like that, multiple product, because it's a matter of your board, matter of next level engineers. You should give you can give that, so okay, we have done some evaluation, looks like this is coarse material, potentially you can extract this much, but that needs investment, that needs characterization, you get some sample, work with the universities like that, lab like that, and then get established some number, and then do something evaluation like that, economics and environmental. That's the way you can propose it. You cannot be easy.
In my PhD, I have extracted, my PhD materials was bottom mass, bottom.
yes.
And iron ore slag, how to extract the elements as well as effective utilize. We have extracted, I have extracted all the elements from bottom mass iron. And one thing I did my PhD, like formation of geopolymers and insulation mix. So what at that time what happened, I used DPL bottomers. I know that. So bottomers having both are in nature.
Yeah.
What is the problem? The geopolymerization reaction requires very high surface area for effective geopolymerization. In this respect, if you see, high is more means in this area, geopolymerization reaction will faster for high, but it is slower for bottomers. And you are talking about the pond ash. Pond ash is nothing but the mixture of fly ash and the bottom. Therefore, if you see the particle size having higher diffraction is fines to portion.
Yes.
You will get. Therefore, bottom ash, if you want to geopolymerize it, means pond ash, you have taken time. This is the problem.
One thing, like the pond ash that we have, that contains both the bottom ash and the
fly ash as well as
fly ash, because all the fly ash that we are generating, we are unable to utilize it. And the storage on a real-time basis is not very much possible. So only 30 to 40% we are utilizing on the real-time basis. We are transporting to the cement factories and all. Rest 30 to 40% of the fly ash part also, that is also getting transported into the pond ash only. So the pond ash contains both the fly ash and bottom ash, and we have segregated separate line for bottom ash and fly ash. So if we want, we can collect the fly ash part only from the pond.
Therefore, it is creating the problem. Like if you want to use like a cement replacement, then the fly ash will be better. Okay, but when it will mixed in pond ash, means mixed with bottom ash to make pond ash, then it is very difficult. Then you have to utilize for making the roads, etc.
The extraction part, sir? The
Extraction part is easier, because if you see the bottom ash having more heavier particles,
yes.
therefore it is bottom ash.
Yes.
Always, if you see the preferential distribution of different metals, the heavier metals will be concentrated more in the bottom. And lighter metals, it will try to go out as a bias. Then if you get that bottom ash or maybe pond ash, then the materials which can tell you like different heavy metals extraction. Then you can get more metals in the bottom ash and The extraction part, if you want to do, then you have to go to bottom or as well as.
Can we get into some research at NIT Durgapur
Yeah,
in the future?
You can Google my document. I think 30% paper will be on bottom and pliers.
I will connect with you later on.
In our plant, the bottom doesn't go to the pond. Only the flyers from DSDK. We have collected bottom from your plant. Yeah, it doesn't go to the pond. Only the flyers only get slurry and goes to the pond. Actually, we have two options for flyers. Either we can send to the silo as a dry form, or we can send to the ash pond in the wet form. But the bottom ash goes away from the plant. It doesn't go to the pond. Some water bodies have advantages. Like if you see, it looks like engineering term it's called the popcorn-like structure. Means structure is like popcorn.
Yes.
Then what will happen? That if you keep the bottom is in a place, then the effective permeability of the bed will be very high. Therefore, we have prepared the insulation bricks from bottom edge, which I recommend patent for preparation of the insulation bricks from the bottom edge. But
Insulation pits.
insulation bricks.
Bricks.
But you cannot prepare that much insulation property in pliers, because pliers having the senosphere sometimes it is hollow, senosphere sometimes it is thick. Then to make insulating bricks, insulation bricks, bottom is the idea. But for geopolymer bricks, pliers will be the idea.
So in this room, how many people have heard about for mineral carbonation?
Of the cement.
So you know what is mineral carbonation?
Yeah.
Injecting carbon dioxide into cement for fuel.
So your
New.
uh,